Right. Okay, we're going to hand over now to Ken Cartwright. Thank you for joining us. Ken, hopefully you can hear me, but can you take it away for us? I know you're going to introduce yourself in a minute, so over to you.
Yeah, I just want to check that the water loss specialist slide is showing. That you can see that slide.
Yes, it is.
Yeah. Okay. Good. Let me just. Okay. There we go. So, my name's Ken Cartwright. I'm a senior associate engineer within AtkinsRéalis. And I've been asked to come talk about non-revenue water and large diameter mains and the UK's move from estimation to using flow balances to report on upstream non-revenue water. I'm just going to leave this statement there for a bit for you to read. But fundamentally, it was something identified within the UKWIR study into best practice for flow monitoring zones. And that is really, within the UK, we may have historically taken our eye off the ball when it comes to monitoring our most important assets supplying water to our customers and the level of non-revenue water across those assets. Some of the slides, I'm going to give a brief overview of myself and my background, specifically with upstream and trunk main non-revenue water. For those international attendees, just a brief overview of how networks in the UK are set up and how we report on non-revenue water. Then going to go into the UKWIR study into best practice of upstream flow monitoring zones, what's changed since that report was issued, and some learning which could be taken on by non-UK water companies, and then a bit about what next. So, okay. So, I've worked in the water industry for 28 years. 25 of those have been with AtkinsRéalis. I'm a father of two over-energetic boys who like to spread germs. So I will apologise now. My voice may go. Give me a couple of minutes, I'll try and get it back. But that's because of them. I'm also a head coach of an under-8s rugby team. I've worked across many areas of the water industry, both within the UK and internationally, covering design, performance monitoring, reporting, solution development, and in recent years, I was a technical lead on the UKWIR study into best practice of flow monitoring zones, and I've joined the AtkinsRéalis Assurance team auditing UK water companies. But what's my history with non-revenue water on large diameter mains? So it initially started in 1998 when looking at the area of Bolton within United Utilities supply area. From that project, it actually turned into a huge project covering the whole of the company, United Utilities area, with multi consultants supplying information into that. I was tasked with looking after Stockport DMZ as well as a few others. Within Stockport, we managed to reduce upstream non-revenue water by 16 megalitres a day, and that included finding a 5 megalitre leak within a treatment works, which was actually being hidden by what we call a wandering zero on one of their water supply meters. A couple of years later, I ran a trial in Yorkshire Water looking at the safe area of the company. And again, we found some real issues. One of a reservoir overflowing 30 minutes twice a day, every day, and a large trunk main leak, which was initially reported as being an unmetered flow used for sweetening flow between supply systems. I have a big gap until 2009, where I helped Severn Trent Water during the Free Store event by balancing their upstream network. And again, there's a big gap until 2020, where I became the technical lead on the UKWIR Upstream Leakage Best Practice for flow monitoring zones. Since then, we formed an Upstream Flow Monitoring Group, and I've also started to help a couple of companies understand where they are with their ability to complete upstream balances and what they need to do to move forward. So again, this is more for international attendees. How do we set up, how our network set up within the UK, and how do we report on revenue water? The process for tackling non-revenue water in the UK was really set out in 1994 by the Managing Leakage Report. issued by WRC. And in this, we split our areas up into DMAs, which is typically a discrete area with one inlet meter, and there could be cascading DMAs from that where the flows are also metered. They're isolated using boundary valves, and typically our mains are 2-inch or 8-inch in diameter, and those mains tend to have many property connections. Just as this plan on the side shows, the sort of shaded areas are what we call our DMAs, with the red mains being our trunk mains or our transmission mains, and the white squares are dots. DMAs cover approximately 90% of the UK network, and they're used every day for managing and targeting non-revenue water. The remaining 10% is formed by mains typically 8-inch in diameter or above. They can consist of aqueducts, transmission mains, pipework around reservoirs and water tower sites, and they tend to have no or very few property connections. However, the one thing identified in the UKWIR project was actually there's still areas of small areas of distribution mains where a DMA hasn't been formed, and these mains are 2-inch to 8-inch and have many property connections. So how do we report on non-revenue water within the UK? Again, within the managing leakage report, there's a system set up called the water balance. And the first method of calculating non-revenue water is called the top-down. So we measure our total water being put into the company, and then we take off unmetered customer usage, meter customer usage, and then some other factors such as operational use, meter error, or illegal use. And what we end up with is basically a top-down non-revenue water calculated number. We then take our DMAs, which cover 90% of our network, and every single DMA, every single day of the year, we assess the minimum night flow. From that, we take off allowances for commercial night use and household night use, and anything we actually log within that DMA. And that gives us our night losses for every single DMA, every single day of the year. That's then times by an hour-to-day factor, which is effectively a ratio of the pressure at night against how that pressure changes throughout the day. And that gives us our total DMA non-revenue water. This forms the first part of our bottom-up calculation. On top of that, we add on our trunk main leakage and our service reservoir leakage, which are generally estimated. And then we complete what's called an M&E assessment or a gap assessment between what's being calculated top-down and what's being calculated top-up. And then that gap tends to be shared across the two elements. When you look at the elements of strategic reservoir and trunk main leakage, a questionnaire sent out in February 2022 identified that most water companies in the UK are using methods of estimation, not measurement. And there's 8 different methods used for trunk main leakage and 6 methods used for service reservoir leakage. The most prominent method used is called BABE, or burst and background estimations. This was started to be used within the UK in 1994 to estimate levels of trunk main non-revenue water. And it's basically a calculation based on length, size, material of mains, historic burst records, historic active leak detection performance, and a perception of condition and pressures across those assets. At that time, only one company were actually using flow balances and measurement to calculate their upstream leakage, and 2 other companies were using some sort of hybrid. Now, I just want to say the approach of the UK using DMAs to reduce non-revenue water has been working. We've seen reported non-revenue water reduced from nearly 5,000 megalitres a day to 3,000 megalitres a day. However, that progress has slowed over the last few years, and with tougher targets to reduce non-revenue water by a further 50% by 2050, the industry needs to start looking at non-revenue water differently. The PALM approach has been developed as a framework to understand how and why we manage non-revenue water, and where there are gaps in our processes and data, and where there's a need to innovate or improve how we do things. However, as DMA non-revenue water is driven down, and the upstream non-revenue water is being estimated, and in most cases those estimates never change, the percentage of total water, non-revenue water reported on our upstream assets is increasing, and we're struggling, and some companies are struggling to become compliant with the gap assessment in that top-down, bottom-up leakage calculation. Something different had to happen. However, that's not quite true. There's one company, United Utilities, who understood that there was actually a gap in how we were calculating things, and they needed to look at the total network, not just on where DMAs were. And they started a journey back in 1998 to look at a small area of Bolton. By 2000, they'd mapped out the whole of their upstream network and started to complete balances across that network. And through the years, they've run many different ways of developing this. And in 2015, they moved away from BABE to actually using flow balances for reporting on upstream non-revenue. This was the first in the industry, and when they presented on their process in 2018 at the UKWIR Annual Leakage Conference, it raised a lot of eyebrows, and that caused UKWIR to sanction the study into best practice for flow monitoring zones and trunk main non-revenue water. So I'm just going to go into that overview of that study. So in 2020, the UK's water research body commissioned AtkinsRéalis to complete a review of best practice for upstream flow monitoring zones. The report was issued in December 2021, and I've actually put a link onto this slide if anyone wants to go to the UKWIR's website to purchase a copy of the study. The study sets out best practice for setting up and utilising flow monitoring zones to monitor and report on non-revenue water. It also identified there was a gap in companies' ability to monitor upstream non-revenue water, and actually there was wider benefits to setting up UFMZs, which included improving the ability to monitor network and operational incidents, to improve network and operational awareness, to provide evidence for further capital investment, and to improve production planning. The document also contains what we call steps to success. So this is more for a company who have nothing in place to understand what they need to do to go from a basically zero base to moving that through the process until they can actually start to use flow balances for reporting on upstream leakage. Just going to go over what are upstream flow monitoring zones, or UFMZs as we call them. There are also other names within the industry: trunk main area balances, tile analysis, or non-DMA balances. These are formed based on the ability to have all inlets and outlets of an area metered. Any main downstream of a water meter supply meter and not included within the calculation used for DMA bottom-up leakage can be utilised. They can be individual mains, they can be a collection of mains, they can include water storage, or be a mix of trunk mains and water storage. In worst case scenarios, the balance is simply your water being measured into your network minus the water being measured into your DMAs. What was the drivers for change for the study? So upstream assets, trunk mains, are the arteries of our water supply network, and they've also been forgotten parts of the network due to the lack of investments in sensing, monitoring and maintenance, due to the fact they have largely been designed out of a non-revenue water calculation by water companies. And this has been given the option of estimating non-revenue water rather than using methods of measurement. Additionally, previous other driver performance measures, such as interruption supply, weren't as robust as they are now, and large bursts causing interruption supply to customers weren't penalised. That has changed in recent years, and actually custom minutes lost is highly scrutinised by the regulator, and this has meant an increased focus on our upstream assets and how they're performing. Supply-demand balances and water stress are also causing issues within the overall water balance calculation, and therefore estimates are becoming less resilient to assurance scrutiny. When looking at that PALM approach which has been developed for our upstream networks, prevent, there's been a problem. We've had no tangible numbers, so you can't really come up with a justifiable benefit And even if you do invest, you can't really measure that benefit. Awareness. We remain reactive to problems on our strategic networks and not proactive, again, due to limited investment in accurate sensing, monitoring and the maintenance of those assets. Locate, so the ability to find leaks. Without awareness, we're still reactive. And although there has been investment in technologies, a lack of money in this area within water companies means there's a lack of adoption of technology. And also when it comes to mend, there's been limited investment in innovation in this area. And I haven't got a picture here, but in recent weeks on LinkedIn, there was a post of someone asking for help for a bespoke fitting to be supplied, and so they can actually fix a leak on a 400mm main because standard fittings wouldn't work.
Ken, Michael here. We've got some problems from static on the line. We can make out what you're saying, but it's not crisp and clear. Is it possible to see if we can do it without the microphone, or is that essential at your end? Is it worse? Okay. We can work out what you're saying. It's not as crispy as it could be.
No problem.
You are right. That is definitely worse.
Is that better now?
Oh, now that sounds better. Let's go and we'll see how it goes.
Sorry. It might also be my throat's getting croaky. So, all right. Just going to benefits and concerns. So there's a number of benefits and concerns identified by the steering group with the UKWIR project. One of the interesting things which came out was a number of companies raised concerns about meter accuracy, connectivity, and it's unaccounted for water. It's not leakage or non-revenue water. However, a number of companies saw those as benefits by using UFMZs, and this sort of showed up. Actually, there's a perception that we know when trunk mains leak, and like this old picture here, you get a jet of water coming out of the main where there's a large diameter main. Reality is that's not always the case, and this shows there was a cultural issue within industry and our willingness to report and tackle on upstream non-revenue water. A key statement which came out during the study was actually, as companies, we have an ethical duty to improve our accounting of every drop of water we extract from the environment and our understanding of how that water transfers around our networks before reaching our customers. Something the study also identified is in developing upstream flow monitoring zones. It's an iterative process. Initially, confidence is low, but as you start to develop them, you start to get a better understanding of where there's lack of monitoring at a strategic level and local level, where non-revenue water is being calculated, whether that's positive or negative, and the issues around how that number is being produced. And that only enable a company to make further improvements and evidence investment need. Key learning, so trend imbalances. In the UK, we love our 15-minute flow profiles for our DMAs. These are normally diurnal in pattern with low flows at night and morning and evening peaks. The whole of the minimum night flow analysis calculation for non-revenue water is based around this flow pattern for DMAs. In some instances on our trunk main networks, we can still get those patterns where the net of the inlet meters minus the net of the outlet meters provide a similar diurnal pattern. However, due to pumping regimes, changes in storage and reservoirs, operational changes of the network, the 15-minute profiles are often variable. You don't have a minimum night flow during the night period, and they're inconsistent and sometimes fluctuate from positive and negative across the day. Therefore, the DMA approach for calculating non-revenue water wasn't applicable. What United Utilities did, and what was set out in the best practice, is you could still take those 15-minute flow balances, even with all that, the noise which occurs on matching lots of meters against each other. And by converting that into daily average weekly flows, you're basically doing a volumetric balance of the water into an area versus the water out. And if that's zero, you know you don't have a problem. What it also shows in areas which the 50-minute balance could be bouncing from positive to negative, is volumetrically, you can start to see that there is actually a problem in the area. And the key thing is about the consistency of that value. We can use these to actually identify non-revenue water. For instance, this is one where we saw a large increase on a weekly balance within an area. And a further look, we identified that a service reservoir had been overflowing for a couple of days. The thing about this, the reservoir was overflowing at 84% capacity, so no alarms were being set off. And if we applied that factor back across previous months, we could actually pick up that these pickups here were also cases where the reservoir was overflowing, but for shorter durations. We can also identify trunk main leaks and see them grow. Although the weekly balance could be slightly erratic, what we can see on the 15-minute thing is there's a large leak, we fix it, and then the leak starts to grow over time. The 15-minute balance is very erratic, but on the volumetric balances, you can still see that occurring. Meters and telemetry. So these was raised as a major concern, and there's reasons for that. We get things called zero errors or fixed offset. These are typically meters which still record a flow going through the meter, even though there is no actual flow. We often see this problem on pump meters. So when the pumps are off, the meter still records a flow. There's full-scale deflection issues. So these are problems where the flow actually going through the meter is higher than the meter is allowed to record. So what we see, a flatlining of the top flow, and then the meter starts to have problems and drop out. We have meter accuracy issues or a percentage flow error, meaning the higher the flow rate through the meter, the bigger the error. And we also get impossible issues. So in this case, a bidirectional meter, which is reading flows in both directions at the same time, but it doesn't always do it. So we don't really know what's going on there. When looking at connectivity issues or unmetered connections and operational changes, flow balances can be quite erratic at times, but by trending the data and comparing it with neighbouring systems, you can see that an increase in one balance can often be offset by a decrease in another balance. So we know there's an unmetered connection between those two systems, and we can start to estimate how much flow is passing. In some cases, you can even start to put a real flow value onto that connection and see when operations are see when and how often operations are changing the settings. Other things we might pick up on, so unmetered process water being taken back into treatment works downstream of DI meters is sometimes a problem within the UK. And recently we found a megalitre a day being used for a backwash where the connection is taken directly downstream of the distribution input meter. We found flows passing between zones where we've been told it's hydraulically impossible based on modelling, or it's simply not allowed due to water quality issues. And we found resilience connections or emergency connections which are actually passing water on a daily basis instead of when they're needed. We've identified large users and demand outside of DMAs, and predominantly our DMAs have issues. They are often breached off our trunk main system, and that causes imbalances in our areas. They've enabled us to improve our understanding just how flow dissipates across our network and where imbalances exist, where we have data confidence is high or low, and where that confidence in non-revenue water is high or low. Setting that out and developing that plan enables us to develop and prioritise where we need additional investment and where we need operational validation. And the best thing about it is we have a tangible number which can vary day by day, but that provides evidence and need for investment. Taking it to a bit of a simple process, what do we actually mean? So we're measuring the total water going into our network. In some cases, we may have water leaving our company and exporting to other companies. We then look at our DMA flows. Now, within the UK, we have assessments called operability, and that's assessment of our confidence in the level of non-revenue water being reported in that area. What we're actually saying here is if we have that higher level of confidence in those DMAs and the level of non-revenue water being reported, then we should have that confidence that those meters are actually reporting the correct amount of flow into that area. So the gap between our DI and our DMA flow is basically our upstream non-revenue water. You can then split that down further using existing meters to aggregate that non-revenue water up. Sometimes you get high positives, sometimes you get negatives, but fundamentally, if the number in the aggregated calculation equals the total number in our strategic balance, then we have a confidence that that's the level of non-revenue water. Our next task is to work out why some balances are negative and why some balances are high and resolve those issues. Taking that back to how we report on leakage non-revenue water to our regulator, we're sort of adding an extra step. We're taking our total water into our network from our top-down balance. We're then taking our total water into our DMAs, and that gives us an unvalidated upstream unaccounted for water. We then need to understand more about the demand of that upstream network and infill any missing DMA flow data or problems caused by DMA operability. And that leaves us with our validated, measured upstream unaccounted for water, which in the end will replace our estimated methods used to date. The problems this will do is it's likely going to cause an increase in reported non-revenue water, but it also might reduce our MLE gap and enable companies to have higher confidence in the total number reported. It also may cause potential challenge to other components of that water balance process. Actionable insight. So what are we actually seeing from these? We can validate our DI meters. We have confidence in those meters that we're reporting the right level of water in, or if not, we can get those meters replaced. System integration. The upstream flow monitoring zones are now being integrated into companies' GIS systems and aligned with other drivers' hierarchies. That's providing improvements to network models. It's allowing improvements to contingency planning and management and supporting investment into smart networks. We can spot reservoirs overflowing, even if it's only short periods during the day. We can spot operational changes. We've got the ability to assess our confidence in balances and identify when that confidence changes week by week, and we can find leakage. So what's changed since 2021 on the issue of the report? As I said before, following the report, Atkins were approached by a couple of water companies within the UK to set up an upstream work group. This is a free group and it's Atkins' investment to the industry. The sessions have been attended by 14 of the UK water-based companies, and we meet biannually. We've had guest presenters from water companies, non-revenue water software providers, and our next session is bringing in some suppliers of large diameter leak detection equipment. What else? So one company have set up an upstream non-revenue team, and in 2022 they moved to a hybrid form of reporting on upstream leakage, where 25% of the company was being based on upstream flow monitoring zones. They had a target to move the whole company and the remaining 75% to using flow balances by April 2025. Two other companies have set up dedicated trunk main non-revenue teams. One company has switched to using flow balances following a review by our regulator Ofwat, and other companies are trying to develop a better understanding of the gap in their ability to report and use upstream flow monitoring zones. Most importantly, in June 2024, the UK regulator Ofwat issued within their leakage performance commitment as part of the PR24 determinations and expectations that all companies would move away from BABE or similar estimated processes to using flow balances by 2030. And they also strongly indicated that companies had that functionality already. They needed to provide sufficient reasoning as to why they couldn't move to using flow balances instead of the current estimation method prior to 2030. Just go into learning for non-water companies. So I do realise that a number of areas across the world don't use DMAs as a method of controlling non-revenue water. But there is still this ethical responsibility to understand how water extracted from the environment transfers across our network. You need to gain your confidence in your key meters putting water into your network or exporting water out of your network. Fundamentally, any equation into non-revenue water is governed by the flows and accuracy of those meters. You need to be able to aggregate that value across your network and not based on actual measurement and not assumptions. Developing UFMZs enables companies to truly understand how water transfers across the network. The other thing is you're actually producing a real measured number, and that means it supports investment need for further improvements in monitoring and maintenance. It can be linked to other drivers to maximise the benefit. You can target improvements and drive down actual non-revenue water instead of an estimated number. You can identify operational issues before they become operational emergencies, such as spotting leaks before they become bursts and cause interruptions to supply. You can improve network modeler accuracy, and that's quite critical in this day and age because models are used more and more to understand operational maintenance planning, production planning, understand the impact of operational changes, whether planned or unplanned, improve the supply-demand balance accuracy, particularly when looking at source reduction planning, or emergency response to source output, outage or water quality issues. Other things, treat your balance areas as assets. It's probably taken a while within the UK for DMAs to not just be seen as being used for non-revenue water. They're now widely used for water quality reporting, customer complaints, performance analysis. And that's really what we're saying about your balance area. They need to be treated as an asset. And you need to align your non-revenue water sort of drivers and hierarchies with other drivers as well. You need to develop balances on existing meterers and understand where there's gaps, where there's need for additional metering. Focus on your strategic balance first, so your water into your company and your water out. Then look at splitting that up into sub-zones or super zones. And then if you really want to go down the route of TMAs and DMAs, then it's worth doing that. The key thing is by focusing at the higher level and then breaking it down, you'll start to understand actually where those programs of DMA implementation may be worth targeting first. Develop asset standards to maintain balance integrity. A common issue within the UK, especially over the last few years, is as we've been investing in our network due to growth and changes in our supply ability, resilience connections have been put in place, and these often have been installed without meters, therefore breaching our ability to complete balances. Trending data is key, regardless of confidence. As you get more used to those trends, you can start to develop consistency in those balances, even if negative, and the changes in that consistency can highlight problems you wouldn't normally look for. Understand the reasoning for errors, and then develop the improvement plans on how you can make those balances even more confident. So what's next? So within the UK at the moment, companies are looking at or setting up flow monitoring zones and starting to understand where they have their gap in their strategic metering or meters across the network. They're looking to incorporate flow balances into their corporate systems and their reporting hierarchies and align it with other drivers. When we look at non-revenue water software use within the UK, the two main suppliers, they have the function to set up and monitor upstream flow monitoring zones within those software systems. But what's been identified is effectively when it comes to automating the infilling of missing data or applying factors, we have to take that data out and apply that external to the system. We need to incorporate change in storage within the calculation, and we also need to improve the ability to understand when a UFW or non-revenue water profile is produced. Is that demand? Is that leakage or non-revenue water? Is it meter error or connectivity? Flow meters. there really needs to be improvement in accuracy and reliability in flow meters. And we need to find ways of reducing costs and no risk to accuracy. The most costliest part of installing the meter is digging the hole and building the chamber on big pipes. And then in some cases where you need to break into that pipe, there's a huge risk to actually resupply the network while that work is going on. And it'd be great if someone can come up with something very simple. You could just dig a small hole, attach a small thing to a pipe, and it would measure the flow accurately. There's also a need to improve telemetry standards. I seriously believe that the bulk of the problems of meter inaccuracy within the UK and our trunk main system is actually down to telemetry and eSCADA standards and faults in how systems are set up. When looking at finding detection technology, we need to find a way of reducing costs for that, because that isn't the money being put into our upstream networks at the moment. We also need to, in some cases, we need to find a way to reduce the risk to the network to improve adoption of technology. And also, predominantly, the bulk of technology used to detect leaks on large diameter mains has been transferred for our DMA methods. And actually, we need to improve that because we have less fittings, we have longer distances to cover, and actually minimum flows aren't happening at exactly the same time. So you need something we can react to how flows are actually changing on this network. Before I go to questions, I'm just going to take you back to a fact, something I introduced in the rugby team. And I often get asked by my parents of the players, so my company CEOs, my stakeholders for the team, why we don't just focus on our better players and we continue to play our children with less ability. My reply is simple. We take a one team approach regardless of ability, but if we don't focus our efforts on the lesser ability players or those players where effort, the amount of effort you put in doesn't necessarily provide that instant benefit, in future years, we could find ourselves without enough players and high enough quality to form a team. This is basically an issue I see we have in the UK with our upstream networks. We focused our effort on our star players, our DMAs, all of our investment, all of our innovation has gone into finding non-revenue water in those areas. And we've forgotten about our upstream areas. And that means now we have a harder job to bring those areas up to standard. Thank you.
Okay, thank you, Ken. Thank you very much. Can you hear me okay?
I can hear you.
Okay, excellent. So we've got a question from Mike that we'll come to in a minute. We've just got a little bit of a clarity from Ian Pepperton from Ofwat. So Ian, you can come on if you want to, because I'm not sure the grammar is absolutely perfect in the notes. It says, just to say, not Ofwat have said don't use BAID, not necessarily flow balances. We're not telling us what to do and are open to more innovative ideas. I think that Ian's saying that we want companies to move away from BAID, but it doesn't necessarily have to be flow balances if they can think of something innovative, if they can think of a different way on that.
Yeah.
If I've got that wrong, Ian, come on and tell me. But I think that's what you're saying in that clarification on there. Okay, so we're going to go to a question from Mike. I think he's from Canada. So he says, you mentioned meter accuracy issues. What is typical for a trunk main meter? Oh, sorry, it just moved. What is typical for a trunk main meter? And what is typical or recommended for meter spacing on a trunk main?
So, water meters as a whole, the most accurate meters are plus or minus 2% as brand new, installed correctly. What is their reality? The accuracy could be all over the place. But what we're talking about is we currently work with plus or minus 2% accuracy. When you go to the oil and gas industry, they're talking having flow meters plus or minus 0.1% accuracy. So, there's a gap in our technology and what we use there already. Something I'll bring up, and I forgot to mention this, but Michael Wilmot, who is in the room, in the last year's Water UK Leakage Conference, he presented on a Monte Carlo analysis he had done on meter accuracy and the impact that has on reported non-revenue water. And actually one thing, and I might quote me if I'm wrong here, Michael, but one thing that sort of showed up is, you know, if you take all the meter accuracies in the thing and apply it to all our meters, the reported non-revenue water has a wide base, a wide realm of what it actually could be. However, when you start to take out those meters, which have the biggest problems, that confidence in a reported number becomes tighter and tighter very quickly. So actually, it's about identifying the meters with the biggest issues and resolving those issues, and very quickly you'll come to a number which is more tangible.
Well done, you were listening, Ken. That's exactly what was said on the presentation. Fantastic. Okay, now we come to an area that I know you're very passionate about. So not just trunk mains, but like pressure as well, or you're very passionate about pressure. So we've got a question here. What's your view on PRV, stroke mini PRV, given that they constantly present a leak or a risk of a leak? So what's your view on PRVs?
My view on PRVs is they are really, really good. They need to, like any asset, they need to be maintained. They help maintain pressures, they help stabilize pressures. But if you don't look after them, then they will fail and they will cause problems. And I love them that much, I have a PRV on my own house.
That is very passionate indeed. Okay, so we've got a question going, which I think Katie Walker's already answered it on there. So the question is, you mentioned issues with missing flows at trunk main meters. What is the reason for such a cut-off, the measurement? And are there certain meter types where this problem occurs usually? And are there meter types where this problem does not occur? So why do we have cut-offs on meter data? And are there certain meters that this is more likely or less likely to happen?
All right, why do we have cut-offs? So depends on how the data is being collected from the meter. So most of the meters we're talking about here are connected to some sort of hardwire telemetry system, and it's generally down to a problem on that telemetry system. So outstations being broken into, being slightly things being tampered with, down to the age of the meter. Basically, the meter's just giving up the ghost. When it comes to meters which are being logged using GPRS sort of comms systems, then these meters are in deep dark chambers and you can just lose the signal there. What type of meters?
Okay. Yep.
Yeah, what type of meters? I don't really know, because I don't think we've done enough work to understand which type of meters have the worst accuracy or have the highest failure rates. And I sort of link this to the thing about PRVs in work I've done on pressure management, is actually the older the asset and the less amount of maintenance has been completed on the asset during its life, the more likely it is to be inaccurate. So with a PRV, if you don't look after PRV, it's going to fail and cause a problem. With a flow meter, if it's really old and you're not looking after it, it's going to cause problems.
Okay. You talk about the telemetry. That's not really the meter that's that problem when we get these cut-offs. It's to do with the telemetry. It's to do with the logger. And again, that's what Katie and that's what Benjamin have put in the comments as well. Here's a completely different question. The common performance indicator applied to DMAs like cubes per kilometre per day, are they still valid indicators at the upstream network?
Oh, I missed that. Say that again, sorry.
Okay, so if we look at the KPIs or the indicators we have in a DMA, we have things like the amount of cubes that are leaking per kilometre per day, or even the number of fittings per, leakage per fittings, things like that. Do they apply at a trunk main or an upstream level?
So yes, they can do, but this is that sort of issue of those methods and stuff have been based on the concept of a DMA, so property connections, whereas on trunk mains we have very few property connections, and actually the issues on trunk mains are quite varied to those in the DMA. So you can use it, but I think at this moment in time, especially if you're only setting up flow monitoring zones for the first time, those metrics are going to be out. So the volumetric number being reported is probably your best guide at the moment.
Okay. Question from Eric. What challenges have limited the use of inline inspection technologies for leak detection in large diameter mains? Is it funding, operational capacity to support inspections, or availability of insertion points?
Funding is the key element. Limitation of, and that impacts the limitation of inspection points, which cost a lot of money to install. The other issue is, and I think I did say this, there's risks around putting things within pipes, and you know, whether those risks are real or not, you know, tangible or not, there is actually a reluctance to put things in pipes to find leaks, especially if the tethered ones tend to have a bit more, a bit more buy-in. But the untethered things, I think there's a real lack of confidence in being able to use those techniques within the UK.
Yeah. I think it's important that you mentioned in the UK, because I think different countries have different risks or perceived risks of that on there. And the UK is still quite conservative about doing certain things in pipes compared to some of the other countries that we come across. So a quick question here again. So what is the best PI? What is the best pressure for diagnostic of the upstream network pipes?
What's the best pressure? I have no idea. I'll be honest.
Okay. Thank you again. So we've got a question from David here. Do you think that the strap-on ultrasonic flow meters has come of age for permanent trunk main metering, given the benefits that it can offer for maintenance, installation costs, etc.?
So yeah, the ultrasonic strap-on meters are a good tool because, you know, I wouldn't say it reduces installation costs, because you still need to dig a hole, you still need to build a chamber, which is the predominant cost, but you don't have to break into the pipe, and that's an additional, you know, that's a huge cost for a lot of meters. Their accuracy maybe is lessened, but actually some flow data with a level of confidence is better than no flow data, so they do definitely have a place.
Okay, brilliant. If we've got any more questions, please put them in the chat. The other thing that I'm just putting into the chat right now is a link to the IWA Water Loss YouTube channel. So we had this presentation from Ken today. This presentation goes hand in glove into a presentation that Katie Walker gave 2 or 3 weeks ago, which you can find at that link that I've just put on there. So Katie gives a case study of United Utilities. It's quite detailed. Ken has given us a more broad brush, but they work really well together, both of those presentations on there. So I'll just put that in there in case you want to look at it. Okay, what about, or how about the use of permanent insertion probes for flow balance analysis, Ken? That's the next question. Yeah,
I mean, again, it's, if it measures flow, it's better than no flow. I just mentioned Katie Walker's presentation. I know she talks about some of the issues they've had with probes, but it's more not about the probe itself, it's about how things are installed. But I know technology and processes for installing probes has moved on since that time. But yeah, flow probes have a place in the market and a place in the area. It's just more about how accurate are they, can they be maintained?
Okay, brilliant. Okay, final call for questions. Okay. It's a good one. I think it is. It's got lots of words in, so I'm going to assume it's good. From Andrew. Trunk main leakage detection technologies vary in cost. Intrusive methods can be expensive, with non-intrusive trunk main correlators being less expensive. Some manufacturers have stopped making trunk main detection equipment because companies didn't buy them. Do you think more focus on trunk main leakage will help manufacturers develop more cost-effective trunk main leakage detection technologies?
Yes, and I mentioned the steering group. This is one of the things we're going to be talking about in our next steering group, because because companies haven't been reporting non-revenue water apart from estimated number. There's not the need to invest in technology in that area. That's going to change. So there is going to be a need. So there will be a need for companies to put more money in available to develop better trunk main leakage technology. And I do know, I've seen a couple of things recently which I think would be wonderful if they actually work. So I'm not going to talk about what they are, but there is that thing of, I think there's a gap in the market there. What I expect from the UK is it might take another 5 years before that investment level's up, really, but I think it will come.
Okay, thank you. And it's worth saying, just for those who don't know Ken, he's been doing a lot of work in this effort. He's been doing a lot of coordinating with manufacturers and suppliers, trying to get them in to come and visit utilities or to visit this forum that Atkins run for the water UK industry. So very much appreciate the help that you're doing on that, Ken. Thank you everybody for your time today. Really appreciate it. Very much appreciate the work that you've done, Ken. This recording will go on YouTube within the next week on there, so an opportunity to watch it if there's part that you missed that you want to revisit. Appreciate your time, and thanks a lot. Have a good afternoon or evening or wherever you are in the world. Thank you. Bye-bye.
Thank you, Michael. Thank you all.
Ken, can you stop the recording now? I think you need more.